Okay, today we are doing a problem can I win. In the 100 game 2 players starts, you turn to a running total any integer from 1 to 10. The player who first causes reach or exceed 100 was FAANG, so that player cannot reuse integers. For example, 2 players might take turns running from given to integers. Return true can force a win, right? So otherwise return false, assume both players play optimally. Okay, so desired total and max choosable integer, and we can only use some of them without replacement. I mean, it doesn't matter which order you choose, so you should go from, I don't know, let's say smallest integer, and then what you want to find out is that so like one can win if we get okay, that's doable. What I'm thinking is that we just try to pick some numbers and then backtrack, right? And then let's say we have total, and then let's say this is the last chosen, which is by default 0, and then we want to do so if total, and then probably we want to do who was the last player. So if total is 0, we return true, otherwise we want to do so if I say if we reach 0 it's false, and then let's say it's 10, I subtract 5, right? And then I'm like, okay, if the first player can force it, so if total is desired total, so current player can win, right? Or he wins. No. Well, this player loses, right? So we do. Okay, so for num in range last chosen +1 max choosable integer +1, and then we do if not backtrack total plus num, and then we chose num. Return backtrack max to no 0 0 0 So if this is true, okay, this almost works. So desired total, let's say 5 and 5. Well, let's say you try 1, 2, 3. Not sure then why. So if next one cannot win, then we win, right? I'm not sure what is the problem here, because okay, let's say you try this. So if you do that 0, 0, I don't know, let's say, so that means that I am winning. 300 times 400, which is like 120,000. Okay, let's say I'm at some zero, right? And if I force 1, right, then I force 1 and I see, okay, can next person win, right? So can I win? No, I cannot win, right? If the total already exceeded, I cannot win, right? Otherwise, if total is small, right, then I try to pick a number, right? And if the next person cannot win with this, then we are winning. Total last Hosen. So that's first player. Okay, so let's see. So if you choose if you choose 10, it says that if I choose 10, right, then next person cannot win, but that is absolutely not the case. Absolutely not the case. Right, so let's say I have 10-10, right? Or whatever was picked, right? Total plus equals print recursion last chosen. Recursion. So we are at recursion 10-10, right? And then I guess we can do a mask. Chosen for none in range 1 max integer plus 1 if not chosen if so let's see, chosen shifted by num and 1 is 0, then if not backtrack total plus none and then chosen and 1 to none, return true. Maybe will work. Okay, one time wrong answer. Max choosable integer and desired is small. Okay. Okay, so if desired total over max choosable integer times max choosable integer minus 1 divided by 2 return false. carry should pass, and it's not that bad. Okay, I mean, not sure how this is a medium problem, but okay. Bitmask DP. So notice that max choosable integer is small, so we try picking all subsets of numbers. Wait, I mean, then I don't have to do that. I can just pick a random subset and then check if, damn, holy, I'm stupid. Or can you do that? What's a query IP, valid IP address? Okay. So let's start with backtracking. We have some current total and we have a mask of already chosen integers. We try making, okay, so the current player can force a win if he picks a number that has not been used so far, and the other player cannot win having the new total and used integers. Otherwise, the current player cannot win. If we slap memoization on top of this, where state is total chosen, where chosen is where the state is where chosen is the mask of already picked integers, then we avoid, then we get a time complexity of total times 2 to n, so this number of states, and for each of them is there are tc.2n states where t is desired total and n is max choosable integer. And for each of the states we try to pick the next number from the n available from the n already not picked numbers. Okay, I mean that's it. The space complexity is O of tc.2n since that is the number of states as stated in the previous paragraph. I guess that's fair. Not strike here. Okay, it's a mess. Goodbye.